So far with our big ideas section, our overview of this chapter, we've talked about the graph of a parabola and how it's similar to something that we've seen before, the graph of an absolute value. We took a look at vertex form and how the h and k values kind of slide this around, do some transformations, and how this makes it skinny. We showed how to get from vertex form to standard form, which is just mathematical operations that you could have done in chapter 8. We showed how to get from standard form to factored form, which is very specifically learned in chapter 8 as far as factoring goes, and what you can see on the graph in these different forms. Now, it's also pretty evident that you can go from factored form back to standard form also with chapter 8 skills, just multiplying, foiling this, right? Foiling and multiplying by 2. So that's not so bad. But getting from standard form to vertex form, this is a procedure called completing the square. Now that will come up in this chapter. So that's a specific process or skill that you're going to learn, completing the square. It's a way of getting from standard form back to vertex form without a graph. The other thing that we're going to do in this chapter is we're going to solve some equations. So if we think of this particular scenario, what if instead of having two variables where we would create a graph, what if we just had one variable, just the x? And we had y was set equal to 0. And we had y equals 2x squared minus 4x minus 6. Now, I think we've done a little bit of equation solving like this. It's always good to have 0 on one side. I purposely set it up this way because it's set up the way our parabola was set up. And think about this. If we're given some equation, some random equation in this form, not necessarily this one, what we're really looking for is the places on the graph. If we were imagining this 0 to be a y, we're imagining the places on the graph where this parabola created by this statement over here crosses the x-axis. Now, does every parabola have to cross the x-axis? Of course it does not. If we have a vertex that's above the x-axis and our parabola is still pointed up, it won't cross the x-axis. Similarly, if we have a vertex where it is here, for example, below the x-axis, and our a value is negative, our parabola would be pointing down. It would never cross the x-axis. So it's possible not to have any solutions sometimes to equations that are in this form. This one, of course, has solutions because this is the exact parabola we're looking for. And the solutions are when x creates y equals 0, that's going to be 3 and negative 1. But you don't necessarily have to have solutions all the time in equations that are set up this way. It's also possible that we cross the x-axis in some really weird location. This one happens to cross at 3 and negative 1, which is what this is based on. But it doesn't have to happen that way. It could cross at some really strange square root value, for example, some irrational number. It could do all kinds of things. So we're going to have to deal with ways of dealing with some of those particular situations with equation solving. But in general, your first process for solving an equation is to change this to factored form, to factor it out. So here we go. Let's factor this out. We take a 2, we did it in the past video actually. We take a 2 out and we wind up with x squared minus 2x minus 3. And then we factor that into x minus 3 times x minus 1, or x plus 1, which of course is exactly what we had right here in factored form, right? So when we're in factored form and we're have an equation set equal to 0, now we use what's called zero product property, which we introduced recently. Zero product property. Zero product property. ZPP. Zero product property. Okay. So zero product property basically says that if a times b equals 0, well then either a or b must be equal to 0. So you can set a equal to 0 and solve, and b equal to 0 and solve, and you'll get your two values. So in this case, this is a, x minus 3, and x plus 1 is b. So basically, in order to continue solving this equation that we have in blue, we have to set x minus 3 equal to 0. Of course, we get x equals 3. And we have to set x plus 1 equal to 0. And we get x equals negative 1, which, of course, are the x-intercepts on our graph, right? That all fits together. That's going to be the x-intercepts on our graph. But typically, when you're asked to solve an equation, you're not going to create a graph. You're just going to factor and solve, right? Now, there are times when you won't be able to factor, and there's times when you won't be able to factor, but it's just the graph would just go through some unusual point, so we have to have a procedure for that. And we'll also have times where you can't factor it because the graph doesn't go through any points on the x-axis. It actually has no solution. So we're going to have to come up with procedures for that. So in this chapter, we're going to learn how to complete the square. We're going to learn some different equation solving skills. You're clearly going to learn how to graph and how to use these different forms. But this is a pretty good overview of the chapter. Good idea before we get to the chapter test to come back to these videos and go over them again. You're going to understand them a lot better after doing all the work that you're going to be doing in this chapter and all the practice that you're going to be doing. So looking forward to this chapter. I hope it goes well. It's our last chapter of the year. So enjoy it. We're winding down here.